Hi, thanks for coming. Hello. Thank you for liking it. Hi, how's it going? Hello. Hello, hello. You can feel free to ask any questions now, by the way. Go ahead. Hey, if someone could start me off, that would be awesome. Yes, so I'm in so at the University of Waterloo in Ontario, I'm in statistics and computer science in my final year. So basically, I have a co-op or an internship after this term, which is ending pretty soon. So I have like a month left of 4A. I do a co-op for 4 months, and then I do school for four months, and then I'm done. So last year, yeah. Hello. Hi. Okay, we got some people. So can someone give me a nice question I can talk a little bit more about? I mean, I could talk about my school if you want. It's not that interesting. If you have questions regarding school, yeah, absolutely. I mean, it's a broad, very diverse topic for my university, of course. Um, so to enter the data science field, I like to repeat all the questions just to make sure. So do you need to be very good at math to enter data science, basically? Um, yes and no. Like to enter data science, as in to do stuff that data scientists actually do, not really. Like you need to understand that in a computer, we have these data structures or just, classes or functions, and we can call them and write them to do stuff. So obviously this is very high level, but to do some data science stuff, you need to be able to make a graph and import some data, and you can do that without understanding really any math at all. But to go down into the really theoretical routes, Like there's a lot of math under the hood of neural networks, especially if you're talking about machine learning. Then in data science, there's like so many books, even just one topic that could relate to machine learning. So like statistics, you could read a whole book about that, which underpins neural networks and still not understand how they work. Even understanding, reading a book about neural networks, you'd still be missing a lot of the mathematical underpinnings unless it's a complete like everything guide, which would take forever. So do you need to know the math to implement these things? To a certain degree, a little bit. Do you need to know like all of the calculus and linear algebra and statistics? And the one that really bothers me is the probability methods. Like people are like, oh, you need to know what a geometric probability model is, or maybe a binomial, or a Gaussian or normal distribution for sure. But there's so much of that stuff like probability that you people claim you need to know, which I find a tough time applying it. It's more so if you want to understand like the deep learning book by like Bengio, the main deep learning book, you would need to understand a lot of math before you go into that. It gives a little bit, but to actually do data science type work, not really. It's just that it does help a lot to do it well. Like if you want to be a good data scientist, you should know it. It would help to implement these models, understanding how they work. Definitely, at least in general, the flow of making a model, like making any neural network or whatever model you're doing, linear regression, it's all the same kind of idea, which is, you prepare a training, a test, and validation set. You are just kind of defining some model and then saying what loss function you're going to use and then updating your parameters accordingly. So every single model does that exact same thing. If you don't at least understand that, it's going to be pretty tricky. So model training theory is what I'm going to put into basically classify what I'm saying there. But a lot could help for sure. Feel free to ask follow-up questions about maybe more specifics on parts I said there, or if that's good, then that's good too. Is it easy to find a remote job as a data scientist? You're from Argentina. Well, hello, Argentina. Is it easy to find a remote job? I mean, not one that's high paying and really good. I mean, even me, like I'll get turned down for a fair amount of applications just due to the fact that, it is a probability game. Like I could be an amazing candidate or you could be an amazing candidate and still only have, a 1% chance of people even looking at your resume. So is it easy to get a data science job in particular? And I mean, pretty much all of them are remote right now. At least there's a lot more opening up. Some people are now going back to the office, but a lot of them are remote. So I'm just going to basically treat remote and job as kind of the same thing. It's not easy, and I wouldn't get yourself down if you don't. And I understand, getting a job is one of those things that you really need. Like it's like you need a job if you're not making money elsewhere. But particularly to data science, I wouldn't get bothered if you're having trouble finding a data science job remotely. To help you get a data science job remotely, which is really what I would be here for, is to help you out. You need to put in a lot of work. Like it's not easy. Like you can't just put a project or two on your resume, state yourself as a data scientist, and then get a job super easily. Maybe you can. It's a probability game, but to maximize your probability, you need to put in a lot more work than just that. And to get by the interview, like there's so many people that will get an interview and then just get stuck because, sorry, one second, because they don't know the fundamentals. And so even if you get a data science interview, you need to be really, really well versed in linear regression, model training, same type of things that I was just saying were important to do data science type work. You need to be able to do all of that and speak it very clearly in not necessarily English, but most likely English. So educate them, basically say how well you know this stuff. So the question again, is it easy to get a job? Not really. You need to put in a lot of work. You need to put in a lot of projects, or at least not necessarily a lot of projects, but you need to have done a lot of projects so you understand a lot of things, and then have a couple really, really good projects on your resume, such as like a web app or a mobile app or something that's really interesting. Which university is good for masters in Canada? We have a bunch of good universities here for sure. Honestly, like obviously I could list off some names that it's just my opinion and what I've heard. Uh, to go to a list, I mean, let's go ahead and look at a list, honestly. So I think this interests anybody. Masters of Data Science in Canada. And I'll see what pops up and I know what's gonna pop up. I just want to show you why. So, oh, actually, this is interesting because when I Google it, it's not actually quite getting what I would expect. Is so Ryerson. I'm not here to poop on any any university. Sorry for the weird wording, but I'm not here to really say that these are bad. But Ryerson, clearly paid a lot to get this to show up, or they did a lot of work in search history so that this actually comes up in search. And I wouldn't really recommend Ryerson University. It's not even, it is kind of a university, but this is not really an amazing choice. Um, let's see what else pops up here. So UBC, 100%, University of British Columbia is a really good choice. I was definitely going to say McGill. So McGill and UBC are really good choices. I mean, I go to University of Waterloo, and that's probably the best choice, I would think. And maybe that's just my bias because I'm already doing that in undergrad. But from what I hear, it's either University of Waterloo or Toronto still. So in Canada, that's the competition in undergrad is, sorry about that, is Toronto or Waterloo, and I bet you the still the same is in masters. Uh, so those are some really good choices. I would say those four for sure, like Toronto, University of Waterloo, Montreal. I haven't even heard of this university unless it's something, that acronym is more complicated. So UBC, Toronto, Waterloo, but all of the ones are honestly really good choices. And the point about masters, again, I've said this before. A lot of people think that it's just about getting a piece of paper, and I get it. Like, for a lot of you, it's to just get into the country. Really, is why you want to do any masters, and not even one in particular. So I totally get that point of view. Just make sure that you realize this is a really important part of your time, and like it's a couple of years. It's sure you can just kind of do it, get a piece of paper and forget about it, but do really think about the people you're actually going to communicate with. Try to talk to professors there and be like, okay, so what are you actually interested in? How can I help you do this? And how is that going to help you? Okay, so obviously don't, when you're emailing them and talking to them, don't make it all about you, make it all about them and how you can help them. But of course, being selfish, you are trying to be interested in something in particular, what they're doing, and try to dig in and find out if they can communicate well and if they're a good person that's going to really build you up. Okay, so that's much more important than the university. Again, not to say that I don't care about the prestige of a university. If you care about prestige, Waterloo, UBC, McGill, Toronto, and I'm sure there's others. University of Alberta actually is pretty well known for reinforcement learning because those people did some work on Coursera and lots of research there. Okay, you have a bachelor's in economics. Yeah, just for background information. Cool. Yep, you can definitely do economics to data science. That actually makes a lot of sense. Economics is it can be very mathy. It can be very statistical. So that's good. I'm having a hard time choosing between software and data science. Both fields really interest you. Yeah, so um, if both fields really interest you, I think that's fine because data science is software, and software sometimes is data science. Like I'm saying, if you got a job as a software engineer, you might even be doing like SQL constantly, or you might even be using Spark or something like that, depending on what you're doing. So, I would recommend just doing projects and thinking more so about, rather than just from a career point of view, really think about, close your eyes, like what fascinates you? Like, do you think about writing an amazing website that people are going to walk over or go to your website and be like, wow, this is fantastic. I love the user interface. I love how it's nice and snappy. And when I hover over things, does it look good? Or do I love like a mobile app when, it's amazing that I pull out my phone and just this really fast, well organized application is doing this work. So does that interest you like a ton? Or when you close your eyes, do you actually think about like a robot walking around doing something crazy that you might think you never know how to build, but you would never know until you try? Or something like, data science has so many different applications. Do you like the idea of maybe like forecasting models where I want to try and predict the future? Not many people know how to do this well to gather data and set up in a company like I'm pretty sure that you're going to sell this much product at this time. Does that interest you? Or, there's so many different applications, and I would really just continue to explore. And also, if you are really passionate about both, I mean, I wouldn't worry too much because they very well mixed together already. Okay. So how to decide the value in K? Okay, so a technical question. This is fine. I can pull up, and I hope this doesn't bother anyone's copyright. If they, if you are, please tell me, and I can take this down. But basically, for KNN, actually, did I have a video on this? I might be able to go to my own because if for K nearest neighbors, basically, it's a as you know a clustering algorithm. And the point of it, let me try to find it. How do I search in my channel? If anyone can, oh wait, I can't. You never mind. You can't even send links in the chat, so never mind. Um, Clustering, yeah. So this, no, that's not going to do it. Never mind. I'm not going to bother. So the point about clustering is to say like, okay, I want to group these data points, just plot a different bunch of different axes. Think about two axes, and then I want to group, say, hey, these points belong to this group, these points belong to this group. And so k-means is one way of doing that, where it initializes these means and then it iterates over and basically figures out like, okay, you belong to this group, you belong to this group. And what is the best choice of k? The best choice of k is, it's called the elbow point. You can look that up. And the point is that, of course, as you increase the number of means, or equivalently the number of groups of data points possible, you're going to have less error. Like you're going to have less distance because you have the points must be going closer to something. But you want a point where it significantly drops off, and then after that, the error goes just a little bit. So basically, you go through all the different values of k that might make sense, like 1, 2, 3, up to 10 or whatever, and then you see the point. You can plot it, the error, and where it really drops off is the answer. Yep, elbow method, which I just tried to explain. Yes, thank you. Seeing the bigger picture of the job market, can you foresee a timeline where the demand of data science becomes too saturated, seeing it's now becoming a mainstream craze of the moment? Well, I mean, no one can predict the future unless you, I mean, maybe if you're Warren Buffett and you make a gazillion dollars off of really thinking about the future and where different things are ending up. It's very difficult to do that. So no, I can't, to be honest. No, I can't just go over and actually, let me just switch this up. I cannot predict a time when that would become too saturated. And honestly, I really, really just wouldn't worry about it. Like, it's an interesting point of view, or an interesting thing to talk about. One second. It's an interesting thing to talk about for sure. Is there a point of learning data science right now? It's something that I really wondered was, okay, here's the craze. It's right now, like it's literally right now. And you are trying to learn this thing because there's a craze and you want to learn it. But then, it takes a while. And if you learn it, then will it kind of be dead or dying by the time that you get there? It is a tricky question. But with data science, honestly, it's just going to be a change of terminology. Like, and you just have to keep up with the right tools and you'll be fine. So don't worry about, not having a job in data science or whatever. It'll be there. It just might not be called data science in the future. Like, because, analytics turned into data science because we started having people that are implementing neural network models and that type of thing. But then there's just going to be higher and higher abstractions over this. Like, so instead of using Keras to make neural networks, it's going to be moving to stuff like GCP and Azure. So, cloud resources that kind of automate this stuff for you. And then there'll be an abstraction above that. So just stick with the main tools, the modern tools if you can, make sure you really understand the theory and everything, down below that most people aren't going to talk about on the job, but still really, really helps you out. And then try to stick with modern tools. Definitely Apache Spark, I doubt is going anywhere. If you can move to the cloud, as much as stuff you can do on the cloud as possible would be really helpful for sure. Krish, I thought you said you were busy, but are there any online internships we could apply? Also, what things increase our chances of getting an internship? Okay. Well, I mean, it's kind of always internship season. I mean, it's more so in the summer, at least here. Uh, I haven't been looking at jobs right now because I have one lined up, but I guarantee you, yeah, if you go on LinkedIn and you type in data science internship, there's still going to be stuff that are recent. There's also going to be some stuff that are still there and older that, you might waste your time applying to and they've already figured it out. But, that's just kind of the unfortunate things of applying. So to answer your first question, 100%, there's data science internships. Uh, Go for it. What things increase our chances of getting an internship? So it's about obviously two steps, but you can analyze it a lot. You have to get an interview, then you have to do well in the interview. So to get the interview, of course, you can technically lie as much as you want on your resume. I would recommend as little as possible because, you really want to be authentic and get an interview because you're you and not because you're somebody else that you wished you would be. And you would never get past the interview stage anyway if you weren't really authentic and you say that you knew the things that you know. Like I could put something random on my resume that I don't know, but it'll come back to bite you. So really don't recommend doing that. Make sure you're authentic in your resume, and you don't necessarily have to say every single little thing. Like if you say you know Java, that doesn't necessarily mean you have to be an expert in Java, but you should actually be able to do some stuff in Java if you put it on your resume. So even if you took a class 2 years ago where you're like, oh, it probably would be helpful if I said I knew C++ on my resume, really think about whether you should put that or not. And if there's something in your mind saying you shouldn't, then I probably wouldn't. So just for the record, I know 10 different programming languages or whatever a little bit. I've seen them all in the past, but on my resume, it says I know Python. Sometimes I put R, sometimes I don't. And SQL really are the main ones. And then a bunch of frameworks on top of that. And if there's something obvious I'm missing, someone tell me. But, I know C++ and C and Java, and, I've seen Scala code, and I'm sure there's other ones. I know a little bit of JavaScript, HTML, but I don't really put that. So I put really what the job focuses on. And so after they'll specify what you need to know. And yes, they might say you need to know these 10 different programming languages. And so you might want to put rough familiarity in them. But really drive home the point that you are someone in particular that is good at doing something, because everybody knows that you are not good at coding at Java and Python and C++ at the exact same time. And if you are, then yes, you can jump between things and look up different things for sure and be decent at it. But you got to be an expert in something. And so I'm an expert in like Python and, not an expert in SQL, but like I know my stuff. Okay, so number one, definitely be very authentic and be specific. Okay, so it's not a bad thing to really focus on I know Python, and that'll make Python look more powerful. Like it looks everything you kind of stretch out, it makes everything look weaker. Imagine it's like a bowl, and this is this weird analogy, but like you're filling it with different things that It looks each individual item looks much weaker when you split it out to so many different things, and it looks a lot more powerful when you were like Python and SQL fill up the bowl entirely, and so they're going to trust that you know that stuff, and hopefully you do. Okay, it's probably realistic. So that, yeah, number one, like authenticity, and I guess number two is specific to the job as well. But really, it should just be you. And I doubt you should be changing your resume too much to each job, because if it's computer vision and natural language processing and forecasting, like sure, you could absolutely pick your different projects. Like you could say show that this is my forecasting project first. But you really should just be someone that has something fantastic done, like an online portfolio that you can show around. So, I would just put, YouTube at the top of my thing and say how many subscribers or whatever, because it shows very authentically that this is me, this is my portfolio. Go visit that if you like me. And then your resume is nothing more than, a well-written showcase of, keywords to get past their computer screening, and just a formal piece of paper that, it looks really clean. It shows you can express yourself very, very, very well. And, all the formalities like school and that type of thing. Okay, so you really need to focus on building that online portfolio. So it's very, very important. Oh, had 10 minutes before the test. Yeah, it's okay if you leave in the middle of while I'm talking, but um, and good luck, by the way. So you really need to focus on that online portfolio if you want to get an internship or a job. Doesn't really matter. You are your portfolio. Okay, so people are like projects, 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 100% projects, except not so much like, GitHub projects that are hidden in Jupyter notebooks, like build a you. All right, so I have a me on YouTube, and it looks pretty good. It's not the best resume in the world by any means, but it's something where you can go to and be like, wow, he knows a lot about this stuff, or she is really good at this, or okay, I've never even seen somebody do this. All right, okay, so it's an online portfolio can be done on GitHub, and I have no problem with using GitHub, of course. Like, it's amazing for showing code, and a lot of employers do look at code if it's there, but make sure that it's, think from like the Steve Jobs, the old Apple CEO point of view. It's like, we don't ship crap. We show things from, give them a really, really good user interface. And even if the product isn't that different under the hood, like, it's still a lot of the same thing, which is true with all these data science projects. It's going to be, a lot of the things are going to be the same between these things, but make sure that your user interface is better than theirs. Make sure it looks a lot better. Okay. And that model, make sure you put a lot of effort into making your machine learning model and it does what you want it to do. That's most important, is in these models. I'm not saying you have to be a complete expert in like JavaScript front end, that type of thing. If you're trying to make a web app, like, it's okay if you half-ass a little bit, that type of thing. But the point is, focus on these projects and make them really, 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 really good, rather than, showing 50 projects on your resume. Okay. So I hope that made sense. If that was confusing a little bit, it's tough because you have to have done a lot of projects to understand all the theory and how to mix projects and make a good project. But then on your resume, put a couple different projects, but then have an online portfolio of whatever. Okay, it could be a bunch of, small projects. It could be one or two really, really, really good projects on your online portfolio. It just has to be you. All right. So I hope that made sense. The point is just to be authentic and be really it's hard to explain it other than just saying, be you. A lot of people suffer from this imposter syndrome where it's like, you learn this project and then put that on your resume. Sure, put it on your online portfolio, but it's not fit for a resume. Like MNIST, I see a bunch of resumes that have like MNIST handwritten digits, which is very well known, like Titanic datasets. You did this, and that's great. Throw that on your online portfolio somewhere where you've done that. Maybe if it's YouTube or whatever, put that there. But it's not really something to really show on your resume. But on your online portfolio, you can do whatever. So I'm being a little back and forth here, and I apologize for that. It's a tricky situation because to get a job, you have to be you, and you have to have done a lot of different things to be good at interviewing, to be good at, knowing what to do to solve a particular problem. So you have to have done a bunch of these projects. But make your online portfolio however you want to do it. Make sure that you want to do it. Make sure that it showcases that you're really, really good at doing what you claim to be good at. So mine in general is data science, machine learning, big data. And there's a lot of different projects there, whether they're big or small. Okay, so if that didn't make sense, ask me another question, follow up on that, what I really meant. But That's the main point, is just be authentic, show off you. That's really how to get a job, and do that however you think is best. But make it so that they can see, your employers can see everything that you've done without much effort and that it looks awesome. Okay. So um, how to decide between data analytics and data science, I think is the question. I'm not extremely talented in math, but can understand the concepts if I spend a lot of time. Well, that's everybody, so that's awesome. I'm leaning towards data science, but also afraid of not being able to stand out. Well, yeah. So I mean, I just went off about it. Um, yeah, you definitely have to stand out, and so it's very much okay to explore a bunch of different regions like analytics, data science. Which the difference between science and analytics is more so we mean like making models and maybe neural networks and machine learning for data science, whereas analytics is you might make a regression or something like that, but you're probably not going to do anything super complicated. It's going to be SQL querying a lot, and maybe some R or Python programming to do some analysis. Okay, so how to decide between those two things? Again, I would really just close your eyes and think about like what fascinates you and think about how to get there. Because remember, I'm here. If you heard my story, I'm here because I really loved video game artificial intelligence. That got me fascinated in how machine learning works. And so this is really where my true passion is. And so I'll create a YouTube channel that, might have some analytics and similar stuff thrown in there. But it's all, I know for sure it's down a particular path because that's what just interests me underneath. And of course, there's money in that, which is awesome. But that's not the main source of driving where I'm going. So make sure you're really, really passionate about what you're doing. And to do that, you're asking like, how do you know which one you're passionate about? Well, are you really passionate about doing SQL queries and some analysis on a table? A lot of people are, and that's totally fine. And not to say that's the whole analytics job. Like there's going to be a lot of, I'm suggesting you do this because of this analysis and presentations, that type of thing. But that's not truly what fascinates me. I like some stuff that's more complicated models that are driving really cool applications like Amazon Alexa and self-driving cars. And it doesn't necessarily have to be you are doing that specific thing constantly for your job, but at least it's using the same type of technologies that are driving the same type of applications. Um, okay, so I know the basics of machine learning, but I really don't know how to make projects like intermediate projects. Can you make some playlists of projects? Yes, of course I can. I mean, I have some projects already that's, I have an image classifier. I have like a regression type model. That's your first machine learning project. I could do a bunch of other stuff too. So agree, that's a good idea to make some more projects for me. It's really that, and I'll answer this the same way every single time, is that you need to just kind of explore other people too. I don't want to move you away from my channel. It's just that there's a lot of projects out there that if you want to do something, the blog is there. I promise you. And I'm not going to say don't use other people's information. I use other people's info all the time. Like there's a lot of really great blogs where if I want to do something, I follow this. I want to do a clustering, do this. So after you've at least explored other people's information and you're still stuck about how to make a project, well, I mean, I just don't think you're trying hard enough, quite genuinely, and I don't mean that rudely. I just mean like, you're gonna get errors and you're gonna be stuck for a long time sometimes. And it's these moments where, you're fighting with Heroku to deploy something for 3 hours is when you really learn how to solve these problems. And Elon Musk interviews people by really just asking them how they solve problems. And so if you're able to, if you've gone through these really difficult problems, which, maybe someone else it's not difficult to, but for you, you really struggled through it, then you're able to remember it well, is what he's saying. Is like if you were really the person that did this project, you would remember how to solve these really difficult problems and be able to explain it very, very well. And so with my main GitHub project, and I don't have a tutorial on how to do it, but I have the code there on my GitHub, Know Your Fruit, and it's also with a partner. Um, I use it links to Heroku, which links, it's a mobile app, sort of, basically a website that links to Heroku Cloud that goes to GCP doing a model. And so I didn't know how to do any of that stuff. Like I didn't know really any of that. So you just kind of fight through it, take a little bit from blogs. You don't need to follow a blog exactly, figure out what they're trying to do, and then just make the search and then see if it works. Maybe it doesn't fit with your project. I don't know. Okay, so hopefully that made sense. And yes, of course, I will continue to make more and more projects. Just realize it's a lot of time for me to do like an hour-long project or whatever, but I do try to throw in as many of those as I can. That's Sharon Pluck. I'll get to that. Thanks to the candid response. Yeah, you're very welcome. Greg, is your older brother as good as looking at you? Yeah, you should introduce me. Yes, actually, he's a very handsome person, and I think he is a good person to date if that's what you wanted, and maybe even more if you were interested. I have some knowledge in machine learning, but when I try to build some projects, there's a clash between and front end and machine learning parts. But the problem is I don't know much about front end. Yeah. Okay, I know what you're saying. So if you want to do a front end app, something that involves front end in machine learning, I totally get that, because I was kind of saying that you want to you want to make something that stands out and that's a good kind of product. And so to do that, a web app is a really good idea to use. The common stuff for Python is like Flask or Django, maybe, even though it's a little bit complicated. And then maybe Node.js, like the JavaScript route as well. It's hard to get away from doing good front end without kind of getting familiar with JavaScript, HTML, CSS, and maybe even the more complicated front ends or frameworks. Hi, Marty. And hi, Archie. Um, so if that's something you want to do, then I would be careful about how much you master these concepts. I kind of think about front end for machine learning more as like just a means of showing off your project. And so, of course, all the work that you do in that area can be important, but I would just kind of follow some blog again, or follow my tutorial. I have a Flask tutorial that shows, how to make a web app. And then that gives you the basics of like, okay, I put a file on this machine, and then I can load that up very easily. To save and load a model, it's as simple as make model, save, and then load. It saves to a file, and then you load it. So if you put that file onto a machine, and then you serve that via the whole request system, which is just really the only thing you need to understand about these front end or web applications is that someone else is elsewhere, and your machine is elsewhere. And then it's just kind of pinging it and saying, okay, I either want to, just get to download the HTML from you, or to, make a, like a post request, which just means like, I want to give you some data and then probably still get some important HTML back. So as long as you understand that kind of simple idea, and then you can set up an app pretty easily if you just follow someone's blog. You don't need to become a master in front end. But to really answer the question of, you don't, I don't know much about front end, so how should I approach the problem? Just kind of half-ass it a little bit is my recommendation, because machine learning, you don't need to focus too much on an amazing website. At least make the user interface solid, although it doesn't have to be super complicated. And then follow someone's tutorial, such as mine, on like making a Flask web app. So, hi Greg, can you cite some good ML projects based on computer vision for interview level? Okay, well, yeah, I mean, I can talk about mine for sure, like the Know Your Fruit GitHub project. So for computer vision, basically, the things that you would need to know for sure are how to make an image classifier. And so that's why I have a video on that. It's about an hour long, I believe, it just really sets up a training set, a test set, and validation set of information. So these are pictures, and then you need to figure out what is in the picture. So generally we use convolutional neural networks to do that. So they're very good at handling spatial information. It's basically, puts a bunch of boxes around the image, and then it converts it does a bunch of math that converts to a feed-forward normal neural network, and that'll output what the class is. So you really, really need to understand those concepts, as well as data augmentation techniques, and that'll come up in pretty much anything. If you type in image classifier in my YouTube video, you can go through that. And then in the real applications today, image classifier is definitely one of them. Sorry, I'm going to drink from my invisible cup again. And then after that, it really goes into object detection to be a little more interesting. So object detection is basically, detecting objects in an image. It says, okay, I put a bounding box over here, a bounding box over here, and here. Maybe you're a self-driving car, you need to do this a bunch of times a second. And so that's where a lot of the applications are lying. It's hard to make an actual project out of that. You definitely can. But definitely really nail image classifying, and then that'll help with the interviews for the most part to move on to the more complicated computer vision stuff like object detection. Nice background. Thank you. I randomly picked a background from PowerPoint. I want to start a career in data science. Where should I start? So I would start with the IBM data science certification, which is, I linked it down below. It's just a really good way to, and it's not, you don't necessarily have to, but it's a really, really good way to, start from the very beginning of data science and, get a gradual introduction. It's very friendly, good teacher, good information. And then it moves you up into, intermediate level. But from there, you really need to learn machine learning if you want to do data science. And so I have a video on machine learning certifications order, basically. So Coursera, what is the order to take these various machine learning stuff? And so I have that video there. Okay, so I would definitely start with the IBM one. Or if you like R, which I don't like R, the programming language, I believe the Google Analytics certification is in R. And, there's some other stuff in that area as well. Okay, so how much does doing an end-to-end ML project help a beginner? Yeah. Okay, so how much does doing an end-to-end machine learning project help a beginner in the field of data science? As quickly as you can, as very quickly as you can, go jump into something you have no idea how to do, and you will one by one learn every single thing. You might spend way longer than you should on doing something very simple, like even just a annoying import error because you don't know how to use this library properly, or you're trying to deploy something on the cloud and it doesn't seem hard when you look up a blog and it's like a couple lines, but there's a bunch of errors that's taking you super long. That is totally okay. All right. So as quickly as you can, definitely jump yourself into doing these projects. It's just that I don't recommend that to most people. I don't often say that because it can be very daunting and you might be afraid of failing and then get kind of shot down. Except, yes, for sure, like doing end to end, which they mean by this, generally having a machine learning model somewhere associated in the app, and then having it, either deploying it on a web app, so like Flask or Django or Node.js, something like that, or putting it on a phone. Okay, so maybe you might even have, you're interested in doing mobile development. You can either put a machine learning model like on the cloud somewhere, like GCP, or you can put it on the cloud like Heroku, kind of an app, or you can put it, there's a way to do it right on the mobile app itself, okay, like on the phone. So you can explore all the different ways of doing this, and you're going to find that it's not just like one particular way, like you find one blog that does this way, but then you find another blog that does that way, and just kind of keep figuring out what you want to do. Be open to getting errors and getting annoyed with these types of things, and it's going to help a lot for sure. So really beneficial. How do you overcome frustration on machine learning projects where, for example, your model isn't learning? Marty, how do you overcome frustration? I'm guessing you're having some problems with a machine learning project not learning, or a machine learning model not learning very well. How do you overcome the frustration? Well, quite honestly, I actually walk around quite a bit. I work for like a few hours or whatever, and then if you actually are frustrated with something, like I take a 5-minute walk or 20-minute walk outside if you can. And also, I think video games are a really good way to take your mind off these things. Yeah, I will talk a little bit. It's not the question he's asking, and Marty happens to know the answer to this question. But how would you kind of improve a machine learning model in general? Well, you would think about whether it's overfitting or underfitting. It's probably underfitting, or it's probably overfitting. Sorry. If you're using like a neural network, you're probably having a difficult time with maybe handling dropout layers, which just means making sure that your parameters aren't too important and it's not your model's not too dependent on some of them. So we might use stuff like dropout or regularization to do that. You obviously need a lot of data for machine learning, and so if you're overfitting, that means you're overfitting to the training set. It just means your model is too good or too specific to the training set, and so it's not able to generalize as much as it should be able to. And if you're doing computer vision, there's data augmentation techniques, which basically means, we still want data, but if you don't have data, then you can kind of make data, like artificial data based off of your existent data, and that's totally valid. Hello, Marty. Hey, hey. Do you have an opinion about Power Query language and DAX? Not really. It's not something I ever really went into. I believe Power Query, uh, like so does that mean the business intelligence route, or does that mean like like SQL? So talk to me about that one. What you mean? If it's like Power BI, then I really don't recommend even doing business intelligence because I don't think it's super fun and that amazing right now. But of course, do your own thing. If that's what you are passionate about, then absolutely go for it. And if I got it wrong and you mean query as in like SQL, then yeah, I mean, just make sure you know SQL really well. For web apps, let's say we need some fancy stuff like sliders. Okay, yeah. Do we need JavaScript / React, or is this doable with Flask? So yeah, Flask handles really just the back end for the most part, and it only really handles the front end, as in like it kind of says deliver this information to the user. To do anything really complicated, yeah, you're gonna need to know JavaScript for sure. It's kind of hard to get away from making a good front end without knowing something like JavaScript itself, and that generally implies React, Angular, that type of thing. So you can do some basic stuff with just using Flask and writing all Python code, but as soon as you want to do something really more complicated, there is some ways to do it, like I believe what's the term, Dash. I think you still might need to use JavaScript sometimes with that. But for the most part, to do something really cool, you're going to need to use JavaScript. There is some other frameworks though, so I forget their names. I haven't looked at too. I think Streamlit. If anyone can vouch for me there, there's ways to just write Python code to do something a little more fancy, I believe. Yeah, mostly you need to learn JavaScript though. If I follow a blog or if I do a half good one front end by just learning for sake, then I wouldn't remember it. So the purpose of doing project is being defeated here. That was your major. Well, yeah. So never quit halfway in a project. You can absolutely quit halfway in a blog. Like if you're reading about something for the sake of figuring out one piece of it, then it's not. Sure, you won't remember the blog, but you will remember what you took, and then that helped make your app. So just really have a vision. And I need to take a drink. Mm. M and DAX are super specific unless you need it for your job. Um, okay. Sharon, so it is the Power BI stuff. That's what they were talking about. Yeah, but so make sure you have a vision is really the important piece here. Is that, you're making a project for the sake of either learning or having fun in general. Hopefully it's pretty fun, or making your resume. Okay. Um, so to do that, you just need to be flexible. I forget who makes the quote, but you need to be flexible about the pathway, as in, you make some initial drawing and you say, okay, I want a mobile app that does some sort of computer vision, and you do some drawings like, okay, I'm going to link this up to this cloud service here, and that'll go to this other cloud service and back or whatever. And then you find for many different reasons that like what you drew initially is just not right for the problem, and you're Googling blogs and that are showing you like, oh, you need to do this or you want to do this, then just scrap it. Like it's totally okay to be reading something and be like, no, 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 I'm going to do something else. So don't think that you're not getting anything out of a project if you're half canceling like a blog. And you shouldn't be completely following someone's blog to do some project unless you are pretty basic. Like if you really, really don't know what you're doing, then yeah, completely follow end to end someone's blog. But generally you take pieces of it because you want to make your own thing. And so you take, some from blog A, some from blog B, and then you make your own project. Be flexible about the pathway of getting there rather than just kind of sticking with your thing, even though it's really, really not working and it's not right for whatever reason, which is fine. You'll still learn, but be flexible. Um, yeah, that's okay. So would you recommend becoming a developer in data science? So if you mean like do you care about the normal developer type skills if you're doing data science type work? Well, yes, you really should. So if you're doing data science, you are writing software. Okay, I've said this before, and basically people seem to forget that yes, you're learning about all the mathematics underneath. You need to know the calculus and linear algebra a little bit more than the software people, even though, of course, everyone doing software is taught these things at a university. They all go through calculus and linear algebra stuff for sure. But for data science, for data scientists, it sticks with you a little bit more, and it's more relevant to the stuff you're applying every single day. But just because that math is maybe a little bit more associated with you, and of course, there's a lot of software positions that still do math very heavy, like graph theory, for example, and combinatorics. But for the most part, there math is going to stick with you a little bit more as a data scientist, and it makes you associated with the idea of you're more on the mathy side when really you are writing software like 100% of the time, unless you're making a drawing that as well software engineers do, you're writing code, and that code might look a little bit different than theirs. It might not be about implementing like a website, or it might be doing an API, but you're writing code no matter what. So yes, I highly recommend getting all those developer skills, at least kind of understanding how to make a website and how information's passed back and forth over the internet. It's actually not that complicated, and it's very well, like if you do it once or twice, then you're going to be able to do it like in many different applications, and it's going to really help out. So all those developer type skills are going to be very beneficial for you for sure. And including talking about the data structures and algorithms type stuff, like you definitely need to go through all of that work and like understanding why a dictionary has a constant search time, or versus a list or an array, why it's like just a linear search time, which is way, way worse. So all of that type of theory of time complexity and the data structures and algorithms also will be really, really helpful on the job. And again, if you're looking for like a FANG level job, if you're looking to work at Facebook or whatever, even as a data scientist, which by the way, most of them need PhD positions, or at least master's, often PhD, then you're still probably going to be drilled about these concepts that all the software people think are really important, like, doing something crazy like dynamic programming, which you might not do on the job, but you need to understand the data structures and algorithms, typical stuff, which, I would recommend probably if you're not doing a university education through that, probably do the Stanford algorithm certification on Coursera would really help you out. Okay. Tell me the prerequisite math resources. Resources? So, to learn math, I mean, math is generally thought of as a university subject. Of course, all university material pretty much is taken from these well-known textbooks, and they kind of summarize it into their own book, and that's what they teach as a course. So, if you really want to understand the math extremely well, that's when I would recommend university education. Is I've taken calculus 1, 2, 3, could have taken 4, linear algebra 1 and 2, and several probability and statistics courses. It'll really, really help you understand all that stuff if you can. For the many people that don't want to pay or don't want to spend that much time on a university degree for learning math, then I would recommend basically just searching out the well-known textbooks for each of the material. There's some roadmaps, and I have one as well, for like the order in which to learn data science stuff. Generally, you would need to learn calculus and linear algebra, at least a little bit, and that's why I'm making my own machine learning course and releasing a video every day to show that when you need particular math to understand these things, rather than saying like go learn calculus, go learn linear algebra, come back. It's kind of ridiculous. But you should definitely know like what derivatives are, partial derivatives as well. The idea of kind of incrementally updating a math model, or really anything, just to get a solution, thinking about it iteratively instead of a closed form solution, because that's generally what you do in neural networks and other models. Simple linear regression and linear regression is really the only time you just have a formula and you plug it in. You really need to know just how calculus and linear algebra work together to iteratively make a solution for these neural networks. Yeah, but I would just, if there's something you want to learn about, you're in a roadmap and they say learn calculus, then really really think about what you need to do that, to actually learn neural networks or whatever you're trying to learn, rather than just reading a whole textbook on calculus. Because if that's what you want to do, just go do it in school. They're going to make you do that. So yeah, I hope that makes sense. Do you need to implement every model, like generative adversarial networks, convolutional neural networks, recursive neural networks, or just use transfer learning to do the job for you because you want to focus more on user interface development? Well, I mean, so do you need to implement them to do the job for you? So if you're asking, yeah, do you just need to use transfer learning? So let me first answer this by kind of saying what transfer learning is. I need to take a drink first. So transfer learning is the idea that, we have model architectures existent already that we know work. And there's a lot of flexibility into how you can adjust these things. For example, a base neural network takes as an input, does some matrix multiplication and nonlinear functions in a particular format to get some desired result. And whatever that result is, that's specific to something. It ends in, say, one node, which might mean you're trying to predict whether this is a cat or a dog in the image, for example, or it's a regression problem. There's one node because you're trying to predict whether, what value this thing is from -infinity to infinity, or as a probability from 0 to 1. But that final thing is dependent on your particular problem. So transfer learning gives us the ability to basically keep all of the stuff that was trained. So we train a model to do something. Other people have done that. And so that trained model, you can pretty much just kind of chop the end off it and then move to your own type of network. And so you're basically transferring the learning. That neural network learned on some other problem, therefore it can learn on yours because the problems are fairly similar. So you would choose something that would be a similar problem. So that in general is what transfer learning is. And can you just use that all the time? I mean, it's something you can use for sure. Like it's not always the right thing to do. You can't just, assume that's the best model of choice is to do a transfer learning on somebody else's and mix it with yours. And also, even if you just do transfer learning, it's not like a binary on or off. It's you do this and then you do a bunch of other work as well to try and see if it's actually a good idea. It's a solution for sure. It's not necessarily the best one, if that makes sense. And I assume you already knew that if you're asking this type of question. But I have difficulty answering, saying like, do you have to? I mean, do you have to implement your own? Do you have to try a bunch of different things? If you're not satisfied with your model, then yeah. But if you're satisfied, if you've made a threshold beforehand, or you realize that your threshold really can't be met if you've tried a bunch of times, then sure, like take whatever is best. Thanks for that extensive insight. You're very welcome. By the way, what resources would you recommend for mathematics in programming? Mathematics in programming, in particular data science. Well, so math and programming, there's a very well-known book for looking at like algorithms and data structures from a very mathematical point of view. There's an acronym for it. I'm forgetting the term. Someone else might have read it here. It's like four letters, and they're the names of the people. But it's like no, so I'd say TLDR. That's not right. There's a well-known book for that, and for mathematics in particular, again, there's usually a book that gives you an introduction beforehand. So for example, in the deep learning book, they have an introduction section giving you some of the information, like linear algebra, calculus, that type of stuff, and then they'll point you, say like, you should learn this first, that we point you here, we point you here. So you might just want to deep dive into something, and if they're not telling you that you need to learn this already, you'll figure out very quickly that like, oh, this is doing a derivative. I should really go understand that first. Would you recommend Tableau to someone who's looking to get a job in data science? The infamous invisible cup, yeah. Tableau is fine. Like it's one tool, and I've been asked about this before, and I'm not going to claim I'm extremely good at Tableau, but in general, it's a visualization tool. But do you really need it? It's becoming very, very popular, and people are a big fan of this, mostly because it does powerful visualizations without really that much complexity, which is great. That's the idea of really everything, is what we're trying to do something interesting without being complex. And so it's showing up on a lot of different like not resumes, but job sites where it's like, you need to know Tableau. Even if they wrote it, you really don't need to know Tableau. It's just one way of demonstrating information. And so, sure, I could also make that argument by saying they wrote Python on their job. Do you still need to know Python because you know Java? It doesn't really quite work that way, because there is certain standards in practice. And so it's kind of easy to choose your own visualization tool and not worry about the practices in place versus, Python versus Java. Like if they're writing Python code, they're really not going to want you to go in and do your own thing. You need to follow the system a little bit. So Tableau is fine, but I think people take too seriously that when you see we need to know Tableau, no, they mean you need to know data visualization. And it's a kind of tricky because you want to put the specific keyword on your resume to match up with that, but not necessarily. I wouldn't worry too much about it. Hello from India. Thank you for loving the videos, by the way. I'm very glad. Hello from India. So started pursuing a PhD. Well, good for you. Is it worth doing a postdoc from foreign? Could I get a job? I don't know the specifics, like what your PhD is, but oh boy, I would be surprised if you've gotten all the way to, you're doing a PhD in data science, and there's not even a bad job you can get foreign. Obviously you'd want a good one, but there's a lot of different jobs here that really do desire like a master's or PhD. And after that, do your thing. Like postdoc is more so like if that's what you want to do. But PhD, if you're trying to get a job, I would just really search for a job at that point. Maybe not expect one within the first week of applying just because you have a PhD, but I wouldn't worry too much if that's what you've done. Will my research paper be helpful for getting a job? Yeah. But if you're going for a good job too, like a lot of them actually require, and I've been straight up turned down from stuff because I don't have like a really publicized paper that a lot of people do. I'm more so focused on the informal tutorials for helping people rather than from a really academic standpoint. But from the academic standpoint, absolutely, like your research paper will really help, and often be literally a requirement to getting a job. You're very welcome. Which resources would you recommend for data science interview preparation? I know you have a video on your channel for it. Okay, by the way, guys, make sure that there's questions after this one, because I don't want to be answering one and then be waiting. So please have something below if you can. So which resource would you recommend for data science interview preparation? So to be good at a data science interview, and let me take another drink from my invisible cup. Okay, that's the same question. I saw you. That's okay. You retracted it because that's what I'm talking about. That's totally okay. So to prepare for data science interviews, you need to be very good at the fundamentals, and you need to be able to explain your project and portfolio. It's really the two things. So The fundamentals, what I mean are training theory. So why you need a test, a validation set, what a loss function is in machine learning. And assuming this is machine learning, if it's really just data science like analytics, then make sure you just nail the SQL and normal coding stuff. But for the most interviews are just going to be 90% on the theory of data science, and then like 5% each on talking about your projects, unless you really make it about talking about your projects, which is important and it's a good thing to do, is to gear an interview towards what you want to talk about. But most of the time they're just going to be really drilling you on data science interview topics like SQL, like model training theory, loss functions, why would you choose a different neural network? Like I've done a computer vision or a couple computer vision interviews, and you really need to know how convolutional neural networks work, about training them, about why they're better than other types of models. And so this really just comes with a combination of things. Firstly, you need to know the fundamentals, and to do that, I would definitely recommend just check out my video for data science certifications ranked, or down below, there's some really just the real basic ones. IBM Data Science, if you're a beginner, it's really going to help that out. Google Analytics as well, but there's more than that. I would definitely recommend the machine learning certification from Coursera, the deep learning certification from Coursera, 100%. Do the deep learning one if you can, if you want to get good at data science interviews. Really helps, that type of thing. And the machine learning course as well is also very beneficial. So check out what I have down below, and if that's not good enough for you, check out my machine learning certifications video for I just released it a couple of days ago, the order to learn which machine learning certifications. That's going to really help to the early ones for sure are going to apply to every data science interview, and the later ones will apply more specifically to what type of field you want. My top two favorite Python libraries are Keras is my top for sure because it makes neural network making extremely easy, and Pandas because that's kind of the catch-all for like just dealing with different data stuff. Is Pandas just a good job of that. It doesn't quite do everything because there's kind of a gap in between Keras and Pandas, and that would be NumPy. So NumPy in the middle is just a little bit of work by basically you would turn your Pandas stuff into NumPy, and then after it's in NumPy, you mix around the shape and do some standardization type stuff, some pre-processing methods, and then you can feed that into your Keras model. Okay. You're a software developer fresher with 7 months of experience. Should I leave my paid job? This is going to be a tough question for me to answer. I'm a software developer fresher with 7 months of experience. Should I leave my paid job for an unpaid or less paid internship in data science to gain experience? Okay, so really good question. And this is tough to answer because I'm not you. But given that I'm not you and I'm speaking from the outside, I would say for sure, make sure that you're financially stable, and that should be given. And make sure that you're okay, as in not taking too much of a risk. But if you know for sure you're in something that you don't want to do, then at least gradually move to what you do want to do. And if you think you're able right now to take the risk and just jump on, like, no, I'm ready to, I can sit for a long time in my parents' basement or in my own place because I have the money for it or whatever it is, um, then yeah, make that jump. Don't be afraid of taking, too much of a risk. But, like a risk, it means a lot of different things. Like make sure that you're okay before you do it. But if you're on a path that you don't like, just really go to it, and that's totally fine. Do we need to learn Python well, or the Python libraries will be enough? Well, Python libraries are in Python. I mean, sure, some of them might be written in C, but like they're Python. So you need to be really good at Python itself. I think what you're asking is, should you learn all of the basics in Python? I went offline. I'm sorry about that. I hope not too many people left. Um, so you really need to go to learn all the Python fundamentals for sure, like functions, like classes, uh, like looping, if statements, all of that stuff for sure. And even understanding how modules work in Python would help a ton. But yes, the libraries do a lot. Like you don't need to know how to do what pandas does without using pandas. You don't need to know how to make a neural network in Python necessarily. Of course, it might be really beneficial in learning various different things, except you don't need, for the sake of software development, to be able to do all this stuff in base Python. The libraries do a lot, but you should be a very, very strong Python developer, not considering any of the libraries. You should know at least how you might go about these problems. If you wanted to make all of pandas in Python, you might have a general idea of how that would go, even though you would never do it because it would take so long and probably not a good use of your time. But yeah, libraries are great. Learn a lot of Python yourself, though. What's the ideal roadmap for learning data science from my perspective? Well, I do have a video on data science roadmap, but honestly, let me just tell you right now. So for learning data science, it's there's so many different angles that you can take. And so people are going to make a video about the right way to learn data science and the right way to do this, the top-down approach, the bottom-up approach, which just means like, do I start from the fundamentals and then go into, implementing everything and then actually using the libraries, or do I start by seeing what libraries are doing, seeing the 5 lines of code that it takes to implement, a ton of math that you don't understand. There's so many different ways to view this. The best way, in my opinion, is exactly what I say in the machine learning, my guide to the order of machine learning certifications in Coursera, which basically specifies, let me just say it now, but feel free to check out that video, and also just the description of that video shows even with links like where to go to get these things. But to learn data science, I would start with the IBM Data Science Certificate, and if you haven't chose a programming language yet, I would choose Python. So I would start with the IBM Data Science, which I do have in the description below. I also have the Google Analytics, which I don't recommend quite as much. It's just Google's name. So do that. That gets you to be a kind of it's kind of intermediate level data science, but you don't know much machine learning type stuff yet. So then you really need to check out my other video where I say do the machine learning course from Coursera. It's really, really good. It gives you all the fundamentals. Do the deep learning certification, again in that video. Really, really, really helpful for solving so many different sorts of problems. Like you can do, after you do that, you then at least have an idea of how you might do forecasting or regression or computer vision or natural language processing or clustering. So many different things, including like dimensionality reduction techniques to help out making any sort of model. There's so much stuff in there that teach you how to just, data science is so general and machine learning is so general. After you learn the architectures of different neural networks and models and you understand how they work, then you can solve pretty much every problem. So you need to get to that step for sure. And to do that, I would take a gradual introduction of IBM Data Science certification, go to the machine learning course from Coursera, Andrew Ng, the deep learning certification from Andrew Ng on Coursera, and then step into what you want to do. Go ahead and take the TensorFlow one as well if you want. What libraries would I recommend to land a decent job? So libraries are in Python, pretty standard. Like if you're doing data science and machine learning, definitely get really good at TensorFlow.Keras. So not necessarily TensorFlow itself because it's a lot complicated and you don't really need that much. Keras is a high level library to do neural network type stuff. So that's what you're going to be doing a lot of the work in. All of them will often say that they'll refer to it as like the Python stack or the NumPy stack, sometimes the Panda stack, which stack just means a bunch of different things. And the things would be NumPy, Pandas, Matplotlib, I like Plotly for data visualization, TensorFlow and Keras, scikit-learn, PySpark is also kind of different outside the niche of those, but still very, very useful. Definitely important to learn. So PySpark is really, really underrated for getting data science jobs. A lot of people don't understand even just how to use it at all. But all of the big data stuff underneath is very, very beneficial. So I have a couple of videos on my channel for that, which I'd recommend. I do have an introduction to NumPy, Pandas, and I think Matplotlib in one video as well. And yeah, those are the popular libraries. Normally they say the NumPy stack or the Pandas stack or something like that. Is it good to do a master's from USA for AI? Well, honestly, I could talk about this for a while, but I would just say yes. Like, it is definitely a good option. I'm not necessarily saying the best option, but a good option to get a master's in literally any university or college from the US is fine. Like, they'd be really good. And especially if you're trying to move to the country, don't worry about getting the super top ones. That's okay. Of course, there's a bunch of really top ones, which would be awesome if you could do MIT, Stanford, Caltech, blah blah blah. But there's so much more than just these elite schools. Even just anything in North America would be really good. And of course, I'm not just going to say that those are the only good options, but most people do generally think of like MIT or that type of thing. You're very welcome. Should one learn Flask and Django? So one should not learn Flask and Django, to be particular. It's kind of just a waste of your time to get really good at both, even though, it might be, of course, it's beneficial. I don't mean waste of your time as in you're literally wasting your time. I mean to maximize your profitability from these things is to get good at maybe at least know the basics of both if you're trying to get a job. That way you can kind of say that you can implement their system, whether it's Flask or Django already. But to become a really big master in both Flask and Django is going to take a lot of time and not really necessary. If you're doing machine learning, I would definitely do the basics of, be able to make a Flask app. If you are particularly trying to apply to a job that uses Django, then, definitely go for the bigger. Django's a little more complicated, go for that. But I think Flask, basic Flask knowledge is usually enough to get most jobs. I hope I do meet you one day. Why do I prefer Python over R? Well, so here's the thing. I'm gonna take a break in a few minutes just to get a glass of water and to use the bathroom. I hope you guys don't leave because it's just like gonna be like a minute or 2 minutes long, so stay there. But to answer that question first, and I hope there's a lot of questions when I come back, Python versus R. Firstly, I like the associated ecosystems in Python a lot more than RStudio. So RStudio is generally how you use R, and it's not necessarily. I'm going to get some people hating me because like, oh no, you can use Jupyter. The R is for Jupyter. It's true. But these generally associated ecosystems, Python, I think is usually better and better maintained in everything really. Like in GCP, you would use probably Python versus R. You would use in Jupyter, like by default, it's almost always Python, and it's better well maintained in Python. And in your own environment, like Jupyter on your own system, it's usually a lot better to do Python. And RStudio, I just don't really like. Okay, I think it's kind of clunky. It looks old because it is old. But the language itself, so ignoring all of those factors, the language itself, Python, I definitely prefer because it's just easier to do most things. And it's not easier to do all things. R is 100% better at doing confidence intervals, bootstrap, all of the statistical type stuff. And that's why it's often thought of as a machine learning language because, machine learning it's statistics, it's applied statistics. But like R is really, really stats. Like it's for confidence intervals and maximum likelihood estimation and ANOVA, that type of thing. And so Python is more generic and it has a better ability to write, do stuff on GCP or various cloud things. It's better to do, like you can do anything you want. It automates everything for you. And R, yeah, you can, like there's stuff to do that, but it's just not as good. It's not as easy. But most importantly, pick one. And so I say on my site to, if you're going on my platform, I highly recommend Python for these reasons. But if you're already good at R, then, it's fine. Like it's not dying. In fact, I believe it's still growing. It's just I don't like it as much for many different reasons. In writing code and just doing really anything other than confidence intervals, I think it's a better system to use. I will answer that question right when I get back, so please don't run away. I'm just going to be gone for about 2 minutes, so I'll see you there. Okay, I am back. Hello. So, hey, right. How do you get fresher level jobs as a data scientist? So, does fresher mean like beginner, like entry level? I'll get back to you after you just answer that question. I want to make sure. Loving the live stream. Would love to see such streams. Yeah. So let me actually talk about that as a subject itself. So, firstly, I love live streaming too. It's really really fun, and I waited until I had a decent amount of subscribers so that I could actually sustain constant questions. So it looks like I have that now if I pick the right time. Truthfully, like I looked last night, and people weren't there. It's just and I looked at the analytics. There was no people there. So if I pick the right time, it seems like I can sustain constant questions the whole time, which is really really awesome, and I'd love to do that. Um, so very much thank you for saying that you're enjoying it. I'm very happy about that. I will try to do it as much as I can. Truthfully, very very busy, and so I'm gonna try and fit it in, at least every few days or so, about at about this time. I'm never going to make, and I never say never, but probably never going to make a schedule as to how often I live stream because that puts a lot of pressure on me to do something at a particular time, and I don't really like doing that. But I would like to as much as I possibly can, and it only makes sense between the hours of about at my time EST 10 to about 2 and mostly around 11 at my time. But I'd love to for sure. So um, yes, my work ethic is inspirational. Thank you. So what skills and which companies we should look up? Well, so the skills that you're gonna need are, well, it depends what type of job that you want for sure. Data science is a vast ecosystem, but the skills that I've already discussed for the most part, which is, on a job, you're a random job, you're going to see stuff like Python, R, SQL. You might see the pandas or NumPy stack, like NumPy, pandas, again SQL, but PySpark, Spark, and maybe even OpenCV if you're doing computer vision. And maybe I forget what it is, the natural language processing one, that's pretty well known. TensorFlow, Keras are your main sort of skill sets. And then stuff will be desired. It's always going to say like Flask and Java and C++ and, JavaScript, HTML, CSS, you'll see a lot is desired, even though you might never see it in the job. But it's good to know these things is the point. So those are the type of skills in general that you're going to need, like actual skills. And then the concepts that you're going to need to know are neural networks, the various models, model training theory, like how you actually train these things. And all the math would be beneficial as well. So what companies you should look up for? I'm actually surprised, and it's not an insult, I'm surprised how often I see this question of what companies to look for is whatever company you want to work for, look them up. And so I don't mean like you should have known the name of every single company that you want to work for, because gosh, I doubt I know like 1% of the companies that have a job that I might want. But of course, there's going to be the main names. Like if you're looking for a Facebook, Amazon job, then you know to apply to those. There's all that stuff in the middle that agreed we don't know the name of. So how do you find it? Well, there's job boards like LinkedIn for sure, and Indeed and that type of thing. They do exist, but you definitely need to go and just kind of search by a list of companies, because it's think about what the web actually is, or what Google search actually is. When you type in machine learning internship, you're going to get stuff that's associated directly with machine learning internships. And this might be involving paying for getting these to come up in search and that kind of thing. You really have to find some company name and then go to their particular spot for applying to a job, and then do that. So what companies should you look for? I mean, what I'm looking for, I'm looking for, a top level job at this point. I've had a lot of beginner, intermediate, and then, to mid advanced, but, I'm looking for advanced, so sure. But you're looking for whatever you're looking for, and I don't know you. If you're looking for a beginner job, then take everything. If you're looking for an intermediate job, decline some. Don't look at every single job, but then look up the intermediate ones. I hope that makes sense. So to what degree is deep learning important for a, thank you for asking. To what degree is deep learning important for a data science job? Today, it is extremely, extremely relevant. And go check out my video on the machine learning certifications order for sure that I recently did on Coursera. It really does outline how important I think these are for, that says machine learning, but for data science, I understand that machine learning is a subset of data science, but it's pretty much associated that if you mean you're working as a data scientist, that you know machine learning algorithms. And if you don't, that means you're actually talking about an analytics job. And just for those, you need to know SQL in general, Python coding, and mathy type analysis, statistics analysis for sure. But if you're talking data science, you generally mean that you'd know machine learning. And so deep learning, it just trumps all of machine learning, like all that stuff like SVM and linear classifiers, linear regression. Deep learning just trumps it. And in fact, it actually just is a straight up like, you can do all those other things with deep learning. So understand the base stuff, but then learn deep learning, at least the different really common algorithms like Bayes neural network, the model training theory and regularization / overfitting stuff on that, and then convolutional neural nets, LSTM, and then the other common recurrent neural network. And then if you want to get as advanced as possible, that is extremely beneficial. So deep learning is really, really, really important. And, I have a bunch of videos on my channel about, I think I even have a full review of the deep learning certification. So feel free to check that out. And I'm going to have links all over the place for that one in particular. It's extremely important. Do I need to learn calculus and statistics? Do I need to learn calculus and statistics in great detail if I have to become good at deep learning and reinforcement learning? Well, I never talk about reinforcement learning, so let me speak to that a little bit. Is reinforcement learning, you can actually learn without knowing much at all, which is very interesting. If you've learned the base reinforcement learning book, if you read that book, then it's going to introduce concepts like conditional probability and a lot of probability-based stuff like Markov chains or an extension of Markov chains, which are Markov decision processes. But what's crazy is that you can kind of understand that stuff without knowing all of what's underneath. You can stare at it and it might take a very, very long time to process it, but you don't really need it as a basis. For deep learning, I think was the other part. Yes. So to get good at deep learning, do you need to know calculus and statistics? For calculus, you really need to know what a derivative is, what a partial derivative is, how to take derivatives, and really the main point of what they are, like what they're trying to do. If you understand that point of calculus, honestly, you're probably good to go for that point. For statistics, well, pretty much all of these deep learning models under the hood are actually, you're kind of modeling some probability or conditional probability distribution. And so to really understand each individual one, yeah, you might need to know the probability models and all the statistics underneath. But to get good at deep learning, no, you don't need to know that. You do need to know how to train models, how to avoid overfitting, uh, how to adjust data sets to get what you want, and to learn the various algorithms, which you don't actually need to know that much statistics stuff for. I should do a review on some of this machine learning and data science boot camps. Well, I would have a difficult time doing that because I haven't done any of the boot camps. So I just in general don't recommend boot camps, but maybe that's just because I've never done one and I'd never see a need of doing one. But unless they're cheap, I wouldn't recommend it. But there's people that have done boot camps and get good jobs afterwards, so I can't just shrug them off. I would have a difficult time reviewing one though. I'm a mechanical engineer and I want to shift my career into data science. I see this one a lot actually, mechanical to data science. It's interesting. And I need to know if online courses are good enough to master data science and get a good job. Well, if you're a mechanical engineer, I assume that it means you're either in or done in undergrad in mechanical engineering. So you have you at least show off that I say that you pretty much need a couple things. Is you need to really show companies that you have proof in learning these that you've learned these things. And so at least a degree in mechanical engineering is going to show off that you are a strong learner and you bypass a lot of the base requirements. Does it directly apply to data science? No, it's quite a shift actually. But of course, a lot of the core concepts you've learned in mechanical engineering are automatically going to switch over, like calculus and probably linear algebra, I would suspect. So to get a good job though, if you're really looking to get a job in data science after transitioning, and this applies to most people, whether it's from mechanical engineering, definitely all engineers, and most other jobs as well, is that you have some degree, you have a piece of paper that says I've worked very hard for 4 or 5 years, but now this is not the direct field I want to get my job in. I want to do it in data science. So to do this kind of transition, what's great is you've already done a lot of the hard work, but now you really need to prove still that you understand the data science concepts. This I really think is where certifications come in handy. Is employers know the certifications, by the way. They know stuff like the IBM data science, the Google Analytics, the Andrew Ng machine learning, Andrew Ng deep learning, the TensorFlow, and the more common stuff like AWS. They might not know the particular certification, but they know at least they could read it and be like, yeah, that makes sense and that's very applicable. So the certifications really would come into play here because it's at least a formal way of saying that you've gone ahead and learned this stuff and you're not just claiming that you know it from your mechanical engineering degree or from your self-study. I don't think it's necessary to do a full-on other degree in data science. Maybe a master's is very a typical thing to do, and I think a good approach is to do a degree in one thing and then do a machine learning or data science master's after. but you still don't necessarily have to do that. I would say the courses and certifications from this point are probably good enough as long as you do the right ones, which I have lots of videos on to say which ones to do, but I've already said that. And um, sorry, I lost my train of thought. So the certifications to do those, and it also teaches you the material. Like it really, really does teach you the concepts that you need to understand to pass the interviews. As well, you do need one final step for sure, is to make an awesome online portfolio specific to data science, which won't take 2 seconds. It's either a couple really good projects, like really, really good projects, or like your whole portfolio of you showing how much you love data science, like my YouTube, where I show off, how much I have a passion for this and how much work, you can see is put into it. So to transition in general, if you have that paper, you still need some papers that say like, I know data science and machine learning, and then you really need still a way to stand out in particular in data science, like an online portfolio. Um, how do I come up with unique ideas for data science projects? Yeah, so I do have a video on how I come up, where I say how I build data science projects, or how I build amazing data science projects or whatever. I do think I want to title a video just how I come up with data science project ideas. And so I've said it before, you definitely need to have a bunch of different blogs and ideas. So, or you need to have followed a bunch of different blogs and tutorials so that you know the different solution methods and the frameworks and the technical ways of doing these problems. And again, the deep learning like certification, that thing, it gives you an opening to computer vision, natural language processing, regression, forecasting, all the different domains in data science, and the machine learning course as well really opens your eyes up to all of these. So after you have an idea, and then you've seen how people apply it by following blogs and projects, then genuinely, quite genuinely, you should be able to close your eyes and say, I think I can gather this data. I want to solve this problem. And it's just whatever interests you. Like, make sure that it's actually interesting to you. People really, really enjoyed in my second year when I was just learning about this stuff, where I did a lot of actually evolutionary programming. So kind of like reinforcement learning in like Pokemon trainers, like mixing up different trainers and having them build the right Pokemon team via basically reinforcement learning. And so that was really fascinating to me. It was very interesting. It wasn't difficult to build something exciting because, I just enjoyed doing it. And so all of the problems where I'm like getting errors here, I'm okay because I want to solve those problems. I actually want to get the solution. So it really does come from just, doing a bunch of different blogs, realizing that they're all just kind of an implementation or a combination of models. Like, okay, we use an LSTM neural network here because we're doing temporal data. This involves pictures, so we're probably using a convolutional neural network. Or this is just kind of a numerical thing like regression or forecasting. Maybe or maybe will we not do like a neural network or a time series model, that type of thing. So gather a bunch of information, and then after you've seen how people apply it, close your eyes, do something that's interesting. Which masters should you go for? Data science, machine learning, or AI? Really, it's a bunch of buzzwords. Okay, so I'm gonna just open this up and say uh, they're putting a word on it to be interesting and unique. So, which one in particular? I have absolutely no favorite of either data science or machine learning or artificial intelligence because they all may or may not mean the exact same thing. You have to read really what they mean, what you're going to study, and also the professor of what they are interested in, what type of work they're doing, and whether or not that interests you. In terms of which buzzword to follow, machine learning, AI, whatever, doesn't really matter. You're just about to graduate a Master's of Computer Science in the UK. How easy is it to get a job in the US, and what steps would you recommend? So that's awesome. Master's of Computer Science is really a good choice for doing really anything. And data science is definitely a good way to do that. So from here, yeah, if you're trying to get a job in data science and machine learning, then if you're just talking about computer science, then I mean, there's lots of jobs for you. If you were just to do like like front end, like if you got good at React or Angular or something like that, that's very popular. You could easily get a job, I would think. If you got good at working on the cloud, the GCP, Azure, AWS, then those are great. If you're talking about data science and machine learning, then definitely take the very well-known certifications, deep learning, machine learning, build up those skills, build a portfolio of data science type work, and you're good to go. Hello, I am currently a data analyst and I intend to transition to data science. Could you please offer me some guides on how to best achieve that? So how to transfer from analytics to data science is very interesting because you already have a lot of the tools under your belt. And it's really just a switch of making models instead. So you probably understand the statistics decently well and like at least graphing, doing SQL, I would think, and general coding, probably pretty good at it at this point. But you want to transfer to data science, and to do that, I would probably recommend just learning neural networks. Okay, so really jump into, and you probably have seen linear regression before. If you've not, make sure you do like the regression type stuff, but really focus on learning deep learning is how I would transition to a data science. So you have all of the statistics and analytics type stuff down, SQL, Python, all of that. And if you don't, then I would recommend learning that. Switch over to the neural network side, and you're suddenly a data scientist. You can build these models, you understand how to basically just how to train a model, and however model that you wanted to pick. Sorry, I stumbled on my words. Whatever model you want to choose, which one you want to pick depending on the problem that you're trying to solve. And if you don't have some particular problem, learn all these different techniques, get very good at solving all of these different problems. And then if you want to get a job in particular as some particular data scientist, even go ahead and make them a machine learning model. I've seen people do this, make a model particular to that company and apply with showing that project, say, hey, I think your company involves something like this. It doesn't need to change their company. It doesn't need to be astounding. It just needs to show that it uses some of the data that they might collect. And then a problem that they might try to solve from a beginner point of view, and they'll be really interested in that. The focus is neural networks, though, for sure. Okay, I'm gonna go for another, I think, 18 minutes, so to stop at 1 p.m. at my time. So make sure there's another like 1 or 2 questions down below, please, if you can. Just asking out of curiosity, since when are you learning data science ML stuff? Like, so when did I start learning data science and machine learning? Well, I started reading about, well, I've been fascinated by the idea, even though I didn't know the terms in like grade 12 of high school. So I started thinking about artificial intelligence, just, the straight up applications and nothing under the hood. And then first year, I kind of got avoided from that because it was all about school. But then after that, and then in early second years, when I really started learning machine learning, data science, and I jumped straight into neural networks as quickly as I could, and that helped a lot. So really, a few years, but I've powered like through like every day, much material as much as I can. So the amount of years of experience is kind of BS of what people say. Like you need 7 years of experience. It's not really true. Like you need to have done a lot of stuff, and you need to know a lot of different things. You're very welcome. Okay, so make sure there's another question there so I can keep talking, please. But I'm going to answer a little bit more into the one above, which was, you should also do a review on the ML data science boot camps. So let me please just talk about for a few minutes why I don't recommend a boot camp. And the reason for that, and it's not because there's not success stories out there already. The boot camps, people just, it's a term that's thrown around that, and they tell you that you're gonna like really fast track your career into data science, machine learning. And if it's not that much money, then that's okay. But the problem is it's usually really expensive, and it's work that you could do by yourself. Same thing with the university. Really, you could learn all of that stuff yourself, except to be honest, a lot of it's boring. And so it's kind of forcing you to learn all of this kind of boring material. A boot camp is forcing you to learn exciting material, like data science, machine learning, actual applications of these things. And so there's no point of them making you do 8 hours a day of something interesting for a lot of money. You can just do it yourself. And if you're not interested in it, then there's no point of doing it at all. Which books do I recommend for ML? So for machine learning in particular, I find that a lot of them, are kind of too confusing and don't show you exactly the prerequisites that are necessary, and that gets a little bit irritating. So if I was to look at the canonical or really well-known books for machine learning itself, I would definitely just consider the deep learning book. Okay, it's a really, really difficult option, but you need to transition to deep learning somehow. Okay, so however you want to do it, I would very recommend getting to the deep learning level. There is some steps in between there, such as the machine learning models that don't do deep learning, but those aren't really that necessary to understand deep learning itself, and I think it's kind of taking away from it. So I would, as quickly as you can, jump to a deep learning, not necessarily the deep learning book because it's extremely complicated, but for a machine learning book in particular, I would probably do stuff that does deep learning itself, which is the hands-on machine learning with TensorFlow and Keras or whatever it is right now. It's I always stumble on the name because it's long. Hands-on machine learning O'Reilly book. The second edition came out not too long ago. That it jumps you very quickly into using deep learning, and from a standpoint that it's actually going to make sense to you, even without not knowing that much information. So that's what I would really recommend. There's some books in there like, statistical learning theory and statistics and probability models and calculus, blah, blah, blah. But, I would learn little chunks of those and not do the super theoretical route unless you're already doing school. And so school will have gotten you past most of the stuff you'll need to just jump straight into deep learning. Because all those machine learning models that don't do deep learning aren't really that good. They're not terrible, but most of the time you'd want to use it. Okay, so that hands-on machine learning book, to answer that question, the deep learning book, if you can read it, but it's crazy hard to read, this is where I recommend Coursera material if you can to follow along with the machine learning course or the deep learning certification at Coursera. You're very, very welcome, Marcia. So which website would I recommend to download data sets from your Python or from Python projects? Would Kaggle be my first choice? Kaggle probably would be my first choice. I mean, there's that common list, and I don't need to say it out to you. You can just do the Google search, which says the most common sites to get data science material from, and that'll pop up as someone's blog. That's the top 5, and you can go take a look at that. Kaggle would be my first choice, though, just because it's well known. I'm familiar with the ecosystem, and it's not going to be confusing to me. But most importantly, you need to do what's actually for you. Okay, so if you don't know, if you haven't done blogs before, like if you haven't really done anything before, then stick with what everybody's done before, like following the Titanic thing from Kaggle, or doing computer vision, the MNIST data set from Kaggle. And once you've done all of that basic stuff, well, then if you want to make a certain project, you need to find data wherever it is. So people love to just throw in like, these are the best places to learn or to places to get data science or machine learning data from, but only if they have the right data that you have, and it's going to come up in search anyway. If I'm looking for data on houses or whatever, then you can go ahead and Google that from Kaggle. It'll probably come up. If it doesn't, go to one of those sites that if you don't just Google something and it comes up with the data that you want, then sure, go ahead and look the first, do that blog search, or sorry, do that search that says, what are the best sites to learn from or get data from? Go to each of those, try each of those, and you'll find the data that you want. And if you don't, then go ahead and make your data set. With our Shia here, we've made a data set before. It's really cool. And feel free to make artificial data as well and make your own project from it's not quite as legitimate if you use your own fake data, but for your own learning processes, it's very, very useful to use NumPy or scikit-learn to generate your own data yourself. Deep learning is a subset of machine learning. So for the people that and it looks like most people are leaving now, so that's okay. I'll cut it off in 10 minutes anyway. Is deep learning a subset of machine learning? You really want to clear up the hierarchy of AI, ML, and deep learning. So let me explain this. So there's so many different words here, and they all kind of sort of mean their definition, and they all kind of sort of don't. So artificial intelligence is really, it means making computers do stuff that only humans could do for a long time, such as like natural language processing, understanding language, like having a computer listen to someone talk and it knows what they said and it can give an interesting response back. Um, and in general, more commonly, what it means is kind of any sort of automated process using data. Unfortunately, is actually what it translates to most of the time. Is even forecasting, a forecasting model which just say predicts the weather. That some people might call that artificial intelligence because it's using like a neural network type model, uh, but the confusion here is that neural networks did allow, such as reinforcement learning, not, sorry, neural network, reinforcement learning isn't a neural network. I mean, neural networks might allow for something like reinforcement learning, which might help a robot do something interesting. It might help it walk around and lock on with computer vision. It can understand what it sees or understand what it hears as well. So the confusion for everybody is that they start hearing about neural networks and artificial intelligence, where neural networks, by the way, deep learning just means using neural networks, okay? It means using neural networks, which is just some model. So deep learning is a subset of machine learning because it's, machine learning means basically making statistical models. It's just really all really all it is. And then it also kind of means clustering as well, which is sort of a statistical model as well. So if that's what machine learning is, deep learning is under that because it just means doing a statistical model a specific type of way, which is with a neural network. Artificial intelligence often, but not necessarily, uses neural networks or equivalently machine learning because that's a subset. And so artificial intelligence uses machine learning, and that's where the confusion is. But it doesn't necessarily. Like artificial intelligence could not use machine learning at all to do a bunch of different interesting things. And so people associate artificial intelligence with machine learning, saying that they're kind of the same thing, but they're not. Artificial intelligence may or may not use machine learning. It may or may not use deep learning. It might use machine learning and not deep learning, as in it might use a statistical model that doesn't involve neural networks. But also, AI might not use machine learning at all. It might use whatever else, just some sort of programming rules. For the longest time, artificial intelligence was basically coded in Lisp or whatever, which is just a way of formulating a bunch of rules. It's saying if then, if then, if then, kind of a non-statistical decision tree, like just straight up like, do I do this? Do I do this? Do I do this? Okay, so I hope that made sense. Yeah, okay, that's good. So I think I'm gonna call it here, unless there's any last questions. Go ahead. Okay, I'm glad that made sense. Uh, yeah, you're very welcome. You too. Yeah. Okay. Looks like there's some stuff flying in. So yeah, I'm gonna cut it off at 1 o'clock for me, which is 7 minutes. So I'm gonna explain these two quickly. You're very welcome. So our data camp, data quest, 365, data science, Udacity, and other platforms worth it, or should I stick with Coursera? So uh, honestly, I can't. I'm not going to judge anything else. Uh, I just know that Coursera itself, if you forget every other site exists, it's pretty much good enough. Actually, it's very, very good. Andrew Ng's explanations of everything cover what you need to know. And, sure, there might be a different approach. If you, for some reason, don't like his teaching, then I would look somewhere else. But if you just think about Coursera as the only ecosystem, I think it's a really good ecosystem. Like it has pretty much everything that you would need. Of course, Udacity might have done some particular some way of explaining something that you might not have understood as well had you got it taught from Coursera, or if they didn't explain something at all, they Coursera might have missed something that you found important. But I think just sticking with Coursera is really good enough. And again, I would shout out my machine learning certifications order, that video I posted a few days ago, to really see which ones in order I think you should do. So based on my knowledge, is the U.S. the country? You're very welcome, Arshia. Oh, sorry, that's not a thank you. That says take a shot every time I say ecosystem. Great. It's I'm thanking you for making fun of me. Based on your knowledge, is the U.S. the country where the highest salaries for data professionals are? You're in the UK, and the salaries are not that bad for data professionals, but U.S. seems better. That's really just a yeah. I mean, the U.S. Pays well. They don't pay well for every single job. There might be, a similar job that pays better in the UK or in Canada or whatever other country. But in general, yeah, for sure, the answer is yes. US pays generally very well. Most, but not all, of the important companies in tech and data science are based there. Amazon, Microsoft, Google, Facebook, like all of these companies are American. So, they're all going to pay very well. And all of the companies that aren't like the super top, even like the middle tiers, most of them are American as well, for sure. And they'll pay well. Okay, I think I'm good then. So yeah, I think I'm gonna drop it off. I can ask one more question or two if you happen to have something. You're very, very welcome. And thank you. I absolutely will. Okay. Yeah, I'm gonna drop off. So thanks so much, everybody, for coming out. Again, if you're just stopping by, I'll let you know that I do not have a schedule for going live, but in general, I will be going live at 11 Eastern, my time, in days, pretty much any day that's not Saturday. I might do that. And so make sure you're subscribed and all that stuff necessary so you can see that. Check out my videos on most of the stuff I say are involving. Check out these certifications from Coursera because I think this is the best possible material to both learn and prove you know your stuff in data science. So check the videos I have for that. And of course, if you're just trying to learn projects, I have some project videos. But follow people's blogs if you're trying to do stuff. Stick with it. You'll do just fine. Be confident. You'll get there. I promise you. Learn the fundamentals. Learn in the right order. I say how to do that in my videos. Learn projects wherever possible. And yeah, so I'll see you probably not tomorrow. Probably 2 days from now or a few. Definitely by Wednesday, I'll have another live stream. Okay. Yeah, you're very welcome. What about freelance for data science? Freelance is possible. I mean, it's like, it's hard to find it unless you're good in the algorithm. Like, even I'm not good in the LinkedIn algorithm with all of that I've done. Like, it's hard to get a job. You would have to cold email people a lot, or be very, very popular. But yeah, it's a great option if you can. I think it's underrated, but it's also not too easy to get started with. You're very welcome. And yes, I'll see you guys hopefully in a couple of days. Thanks so much for stopping by. Bye bye.